Welcome to lesson 100, solving quadratic equations by graphing. So when we are graphing quadratics, we are trying to find the solutions to these quadratics. And the solutions to these quadratics are always trying to find out what is the x-coordinate on our coordinate plane. So the solutions of the equations are also called our roots, which we just learned a few lessons ago. They're also known as our x-intercepts. So when y is 0, what is our x? And so those are also known as our zeros. So when they're asking you to find the solutions, they can be described 3 different ways. There can be one solution, which means you have one point that crosses the x-axis, which is at the vertex. So what is your x variable of the vertex? They could have 2 real solutions, which means the parabola crosses the x-axis in 2 places. So those are your 2 zeros, or your x-intercepts. Or you may have no real solutions, which means your graph does not touch any part of the x-axis. Now, if you say that's one real solution, you have to tell me what the x variable is. If you say it's 2, you have to explain or write down what the 2 x values are. If it's no solution, just write no real solution. So let's look at an example. Solve the quadratic equation by graphing. So we have x squared minus 36 equals 0. You notice I'm missing the plane x term, the middle term. Anytime you are missing the middle term, your axis of symmetry is always the y-axis. So I'm going to draw my axis of symmetry on the y-axis. Now my axis of symmetry always goes through the vertex. So if the vertex goes right through there, if x is 0, I also have my y-intercept as my vertex. So we were told that the last number in your quadratic equation is your y-intercept. So it would be 0 and negative 36. So we can take care of 2 points, or two parts of that with 1 point. So I'm going to count by, let's count by 4s. So this would be a negative 4, negative 8, negative 12, negative 16, negative 20, negative 24, negative 28, negative 32, and negative 36. So if this is our negative 36, I'm going to plot my point here because that's my vertex. That's also my y-intercept. Now we can find 2 more points. Now for this one, to make it easier, I would just factor this equation right here because that is a difference of 2 squares. So what do I multiply to get negative 36? That would be a negative 6 and a positive 6. And I make both of them equal to 0, just like we did a few lessons ago. So here, x would equal a positive 6. Here, x would equal a negative 6. Now, if I come to my coordinate plane right here, let's just count by 1s. Here's 6. Here's 4, negative 5, negative 6. Now I can plug my points. I have 0 and negative 6, 0 and positive 6. Okay, so then this would be, I have 3 points. I can draw my parabola. You can see it crosses the x-axis in 2 places. And the 2 places would be x equals 6 and x equals negative 6 would be my 2 solutions for this equation. Let's try the next one. Negative x squared minus 2 equals 0. Again, our axis of symmetry is the first thing we should be finding. You can see that I'm missing the middle term. It means that's my y-axis. So the y-axis is the axis of symmetry. I can find the y-intercept and the vertex because they're both the same. When x is 0, what's my y, which is the last term of the quadratic equation, which is at -2. So if I'm just going to count, here's -1, here's -2. If I put a point there at 0, -2, I just need 2 more points. You notice that this has a negative x squared. It means my parabola is opening downward. So if I pick a point, let's just say I'll choose a point to the right of the axis of symmetry. If x is 1, what is my y going to be? So if I have a -1 and then square that, -2. 1 squared is 1. Negative times 1 is -1. -2 is a -3. So I have 1, -3. So if I plot that point down, I have 1, -3 would be here. I can mirror that to the other side, and I can draw my parabola. You notice it does not cross the x-axis, so this is no solution. There's no x value that will satisfy this equation. Let's go to another one. X squared plus 16 equals 8x. The very first thing I would do is make this equal to 0. So this would be x squared minus 8x plus 16 equals 0. Now I can find the axis of symmetry. The axis of symmetry, if I use x equals -b over 2a, I end up with a -8 divided by 2 times 1, which gives me a +4. So x will be as +4. Here's my axis of symmetry. I'll go to the other side, -4 to be -8. This is a +8. I'm going to draw my axis of symmetry at +4. That's where it's going to cut my parabola in half. Now the vertex has to go straight through there. So the vertex, if x is 4, what is my y going to be? 4 squared is 16. 16 minus 32 is a -32, or -16. A -16 plus 16 is a positive, is going to be 0. I have 4 and 0 as my vertex, so I'm going to put a point at 4, 0. So that's the turning point of my parabola. Now the y-intercept. Find the y-intercept. That means my x is 0. My x is 0. This third term is going to be my y point. So that's a +16. If I plot that on here, well, let's count by 2. So 2, 4, 6, 8, 10, 12, 14, 16. So there's 16. I'm going to plot my point here. And I'm 1, 2, 3, 4 steps from the axis of symmetry to the left. So I go 4 to the right. 1, 2, 3, 4. So I'm at 8, 16 over here. I have my parabola I can draw. You can see it crosses only in one place. And what is my x going to be? It crosses when x is 4. So I only have one solution, and x equals 4. Let's do one more, and I'll have you do some yourself. So here, 3x squared minus 147 equals 0. I would first factor this out. So this would be 3 times x squared minus 49 equals 0. And the reason why I'm doing that is because I can factor this even more. So this would be 3 times x minus 7 times 3 times x plus 7. And this will equal 0. Okay, remember our first step is to find the axis of symmetry. Again, I'm missing the middle term, so that means my y-axis is the axis of symmetry. That means when the vertex is 0, what is going to be my y? My y is going to be a negative 147. Now to save some space on here, I'm going to count by 21s. If I count by 21s, this would be a negative 21, negative 42, negative 63, negative 84. This would be a negative 105, negative 126. This would be a negative 147. So now I can plug a point here. That's where my vertex is, the turning point. That's also my y-intercept, so 0, negative 147. Now 2 more points that I need to plug in. You can see that when I factored this, I can make everything equal to 0. Okay, so I don't have to worry about the 3. If I want to make x minus 7 equals 0, I need to add 7 to both sides, so x can equal 7. If I subtract 7 on both sides here, x will equal a negative 7. If I come over to my graph now, here we go, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Now I can plot those. These are my zeros, my roots, my x-intercepts. So if I put a point at positive 7 and a negative 7, I have 3 points that I can draw my parabola. You can see it crosses in 2 places, here and here. What are my 2 x terms? Positive 7 and a negative 7. Those would be my 2 solutions for that quadratic equation. Now there's a couple other problems you can do yourself for extra practice. You can always check Teams for the answers to those when you've done those. So the second one, solve quadratic equations using a graphing calculator. So here, put out my graphing calculator. We are going to solve this one to find the solutions. For the very first one, I have negative 6x minus 9 equals x squared. I want to put that in as a trinomial equal to 0. So this one, I'm going to rewrite this as a negative x squared minus 6x minus 9. Now I come over to my graphing calculator, turn it on, and I hit the y equals button. Just going to clear what I have here. Just again, make sure plot 1, 2, and 3 are off so there's no black bar over them. And I need to put in this equation over here. So I have a negative x squared minus 6x minus 9. And if I were to graph that, there's where my parabola is going to be. Now you can see that it crosses the x-axis in only one place. So there's only one x value that it will be in. One way to find it is if you hit the second button and go over to graph and hit graph, you'll see a table. You want to find out what is the x value when y is 0. So if I just click on the button that goes up, I want to see where y is 0. So when y is 0, x is a negative 3. So that means for this one, you would have one solution, and your solution is x equals a negative 3. we were to do the other example, go back to the y equals, I want to make that equal to 0. So to do that, and make everything over to the left. So you would have a positive x squared. So I'm just going to delete the negative. So I have a positive x squared. And then it's going to be a minus 6x. But then it's going to be a positive 13. If I graph that, you can see that my parabola does not touch the x-axis. So this one would be no solution. There's no real solutions. It will never touch the x-axis. So that's just another example of you can verify your answer by graphing it on your graphing calculator. If you want to practice some more, here's a couple other problems that you can do. An application problem. Gil drops a baseball from top of a platform 64 feet off the ground. The height of the baseball is described by the quadratic equation. H equals negative 16t squared plus 64, where h is the height in feet and t is the time in seconds. Find the time when the ball hits the ground. So if you were thinking, here's the platform, the ball's up here, Gil drops the ball, we want to find out when does it hit here. So we want to find that part, which will be when y is 0, what is your x? So if I take this equation here and put 0 as the height, because the height's going to be at 0 when it hits the ground. So 0 equals negative 16t squared plus 64. Now here, I can just factor this equation here. I notice that if I take out, let's just say if I take out a negative out of each of these. So if I take actually let's take out a negative 16. So I have 0 equals a negative 16. That leaves you with t squared minus 4. And now you can see in parentheses, I have a difference of 2 squares. So 0 equals a negative 16 times t plus 2 times t minus 2. Now we need to only be dealing with positive time, when the time is a positive amount. So if I make each of this equal, withdraw that equal to 0, I look only with the ones with the variables. The 16 doesn't matter if that's negative 16 or positive 16. If any one of these equals 0, the whole thing is equal to 0. So here, if I subtract 2 on both sides, t equals a negative 2. Here, I add 2 to both sides. I have t equals a positive 2. Why? We just said that the time cannot be a negative value. So that would leave us with x equaling 2 seconds. So 2 seconds is when the ball will actually hit the ground after it's dropped from Gil at 64 feet up in the air. And I have you do the second application problem yourself. Your assignment for next time would be 1, 2, 6, 8, and 19.